What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to prove if a triangle is right-angled using Pythagoras' theorem. This is an incredibly common exam question, but sometimes my students go, well, I didn't know what we had to do. I don't understand what the end goal is for these questions. These types of prove questions are going to come up again and again and again all throughout maths from now until year 12. So it's really good to get on top of them early. Knowing what the question actually wants you to do will make it way easier to get full marks. So a super common question would just be something like this. Hey, prove that this triangle is right-angled. And so sometimes you don't know what to do because we've got all the side lengths. So what it's actually asking us to do is show mathematically why it is right-angled. Even though the triangle looks right-angled, that's just maths teachers being mean. You still have to justify your answer using some calculations. So some of the words you might see for these types of questions are like, oh, show you're working, explain why, justify this, or prove it. Anytime you get something like this, we're not trying to find an answer at the very end. We're not solving the question. We're trying to show our knowledge in a different way to prove something is true or not. For these right angles, we know for sure that a squared plus b squared is equal to c squared. That's Pythagoras' theorem. So that means if this is not true, the triangle can't be right-angled. And that's where this proof comes from. So basically, we're just playing a big game of true and false. If a squared plus b squared does equal c squared, well then that triangle is right-angled. But if it's not true, then it's not a right-angled triangle. So all we're trying to do is prove that the mathematical sentence we create is either true or it's false. So this triangle here, prove that it's right-angled. It's got 4, 6, and 8 as its side lengths. So I know that it's 4 squared plus 6 squared is equal to 8 squared. If this is true, it is a right angle. So this is the same as 16 plus 36 is equal to 64. 16 plus 36 is 52. And 52 is definitely not equal to 64. They're different numbers. So that means that this sentence is false. So it's not a right-angled triangle. That's all you have to do. We've shown here that this triangle does not fit into Pythagoras' theorem, so that's all the proof you need to show. You've justified your answer using mathematics, and you haven't just said, oh, well, it looks like a right angle, it must be. Another way to do this, instead of doing both sides at the same time, is you could just add the two short sides together squared and see if that's the same number as the hypotenuse after you do all the working out. We're going to see that in this example here. So I've got 3 squared plus 11 squared, which is equal to 9 plus 121. 9 plus 121 is 130, and I'm going to root that answer. When I do square root that, the answer is 11.4. But this needed to exactly equal 12 for it to fit into Pythagoras' theorem. That means that this is not a right-angled triangle and it must be something different. For this last example, we've got 3, 4, and 5, and I'm going to prove this using the first method. So 3 squared plus 4 squared has to equal 5 squared. That means that 9 plus 16 has to equal 25. 9 plus 16 is 25. So 25 equals 25. That is a true mathematical sentence. So this triangle here is a right-angled triangle. So we didn't learn anything new today. We already know what Pythagoras' theorem is and how it works. But when we're asked to prove whether or not a triangle is right-angled, all you have to do is go through Pythagoras' theorem and show that it is true for that triangle. If it's not, it can't be right-angled. Thanks so much for watching this lesson, and I'll see you later.